Hello, my name is David Kubon, and I am a full stack developer at Salsita Software. This brown bag is about predicting sports using artificial intelligence. And while it sounds fun by itself, I bet, we will also explore the possibility to get rich with betting using these predictions. There are a couple of reasons why you could be interested in knowing a result of a sporting event beforehand. You might want to impress all your friends by your super correct predictions. You could be a know-it-all who's unfortunately not knowing that much about sports. Or something very current, imagining all the events in Tokyo during the ongoing Olympics that take place at night. You are considering getting up early to watch the games, but you're waiting your sleep and thinking about the possibility that the event will be super boring and you don't know if it's worth it and maybe your favorite team will lose. Well, if you know what happens, then you can wake up only to the good games, right? Or finally, you just want to get rich and quit your shitty job where you cannot bill anything. Okay, so what sports are popular to predict and what methods are typically used? Looking at that slide, let me just fix something here and here. Okay, so these numbers come from a survey paper that analyzed approaches to this topic by other researchers a couple of years ago. You can see that basketball is very popular, along with volleyball and football. The most popular methods use artificial neural networks, be it simple forward neural networks or some recurrent ones, it doesn't really matter. The popularity is probably because you don't need to be very smart to use them for these kind of problems. And yes, we will use them in this presentation. Another really popular method are decision trees, which I explained in my previous brown bag about intelligent engines. So if you want to learn more, you can go back to that one. Those are also really easy to use. You can imagine very basic rules like if a team is ranked higher and playing home, then predict victory for that team. Or if Slovakia plays the Czech Republic, predict Czech victory. Or if it's football, if a match of England comes to penalties, predict loss for England. Very simple. Okay, so it can easily be noticed that in many sports that are popular for predicting, they share similar features. Typically, there are some points for the team and some points against the team, both of which you can consider like for entire season or in just previous couple games. Then there's overall performance, which again could be like a season ranking in the league, or just performance in the last couple of games, like whether the team has won at least 2 of its last 3 games. Then you can consider the home and away performance for the particular team. That would be the case for football, for example, or some venue specifics. Here you can think of tennis and the surface they play on, whether it's clay or grass or concrete. And last typical feature is ranking, where in tennis this could be the ATP or WTA ranking, or in football, again, like the season ranking. I won't go too deep into how a neural network on the right works and how it is trained, because you've probably heard it 1,000 times already. You feed it data, it does some magic in the hidden layers, and then it outputs something. And during supervised training, which is the one used here, you check the output and you tell the network what it was supposed to output, and then you let it readjust. And then obviously during actual prediction, you only take its output because you don't know what it was supposed to output. So here in this problem, we feed it with the features for both of our teams or both of our players, and we expect the result of the game as the output. Using some very simple experiments, you can easily find a, let's say, minimal viable set of necessary features for the sport, which typically are those written on this slide. And then, unless you do very wrong, any additionally chosen features will make very negligible difference. To give you some perspective, you can easily get over 50% accuracy in football prediction with a weekend project. Let me just go a little deeper on how the sports could differ. As an example, let's have a look at two popular sports, football and tennis. They can both be predicted using the features I described in the previous slide, but there are some important differences. Mainly, in football, there is a win, a draw, and a loss, while in tennis, there's always only a win and a loss. Obviously, having only win and loss is easier to predict. What you can do with draws, of course, you can have a bigger output that will have all these three options, or you can predict, like output a draw, if the prediction for neither a loss or a win is not very convincing, meaning the percentage of the probability that the match should end with that win or loss is very low. In football, also, it's been observed that mostly the home team wins. So you can easily get over 50% accuracy with just predicting the home team to win. In tennis, there's no home advantage, but you could predict the player who's playing better at the specific surface as the winner, but it won't work that well. Another major difference is that in football, there are many players, and major injuries or transfers can significantly affect a team's performance. Then you could consider some like strength of the players as part of the features. Some papers went so far that they used ratings from a video game to predict the team's strength, and then like calculated the strength without the specific players if they transferred to another team or got injured. Don't be confused with the success rate, because predictability does not imply profitability in terms of betting. Because if it's more predictable for you, it's also more predictable for the bookmakers. So which sports are popular and how well can they be predicted? There's some American football. Actually, the second item is an extension on the first one. So if you think about it longer, you get better results. It shows that NFL is pretty predictable. If you want to do horse racing, it's pretty exhaustive because there's a lot of horses. But you can still do pretty well. Football is not that predictable, and tennis, as I already mentioned, is about 65%. It could also be that the age of the papers makes an impact on the accuracies, because it could be that like in future, like later seasons, some team is very dominant, then it is easily predictable, and then the percentage overall changes, because obviously these didn't use the same data sets. So if it's that easy to predict it, why isn't everyone doing it, right? Is it illegal? Where's the catch? Well, it is not illegal, and these methods are used very efficiently. They are used very efficiently, especially by the bookmakers. And trust me, their predictions will likely be much better than yours. So Does that mean that this presentation is over? We can make no money. There is no point in trying. Um, I mean, I'm hungry, but no. They are better at predicting, but they also do one other thing, the bookmakers. They publish their predictions in the form of betting odds, and we can take advantage of that. So here you can see a couple of games and the odds. If you've never seen it, the one left column is for home win, X in the middle is for a draw, and the column on the right is for an away win or a loss for the home team. These are actually odds for live bets, but for purpose of this slide, it makes no difference. Just if someone is very accurate, then they could notice. So, okay, so we, instead of trying to build a model to compete with the bookmakers' forecasting expertise, we can use their publicly available odds as a proxy of the true probability of a game outcome and use that to our advantage. The question is, how accurate are these predictions of the bookmakers, and can we rely on them? From here till the end of this presentation, I will be mostly following a really nice paper from people who spent a lot more time on this topic than I did. So they took data from 32 bookmakers, almost 500,000 games from 800 something leagues over the course of 10 years. To consider a match, they had to have numbers from at least 3 bookmakers. So what they did, they computed something they call a consensus probability. It's 1 over the mean of all the odds given for a given game and a given result. That means like all the odds that were given for a given game and a home team win, a draw, a home team loss. Then they bin the data according to this consensus probability into 80 bins. Each contained at least 100 games. And they calculated mean consensus probabilities across the games and mean accuracy of game result. If you don't understand any of this, it's not really that important for the rest of the presentation. So no need to leave the call. Consensus probability, and that is the key point here, turns out to be a really good predictor. They use linear regression, and the correlation of these consensus probabilities with real results was almost 1 for all the 3 possible outcomes. So that's really good. But OK, so if the true probability is so close to the consensus probability, how can we beat the bookmakers? Because the true, well, we can. And it's because the true odds are not the ones that they publish. So let's make a little side step into how bookmakers make money. A fair bet is when the expected value of the bet is 0. So if you bet your friend that, I don't know, another colleague of yours is going to, I don't know, not finish the project on time, and you bet $5, that's a fair bet because one of you will pay $5 and the other one will get $5. The expected value is 0 of the bet. On the other hand, for example, in roulette, if you bet on a red, the chance of that happening, it's American roulette, is 18 over 38. So a fair bet would be if you got paid 2.11 times more than the value you bet, but in fact, the casino will only pay you twice, which is below the fair value. And in sports, the predicted probabilities are only a baseline for odds. So typically, they are set below fair value so that the bookmakers can make money. But, and this is the attractive part for us, sometimes they can be set above fair value. It could be to attract clients. It could be just because your fair value is calculated from multiple bookmakers, and the prediction for one of the bookmakers was a bit off. So what they consider below fair value is above the fair value you think there is for the match. Or they do it to have a balanced book. That means basically to avoid getting overall exposed to risk when many people bet on a specific outcome of a match. It typically happens, for example, when it's when the national team is playing. So usually people bet for it to win. So then they offer above fair value for the loss of the national team so that they could balance out the risk. Okay, so we know that the bookmakers' predictions work well, and we found a little hole where we could maybe earn some money. And now it's time to verify if we really can. This is a really nice formula, and I won't go into detail how it is derived. You can find it in the original paper. And this formula tells us whether we want to bet on a specific match. Omega, again, is the set of all odds for that outcome. And we bet on the highest odd, that is the one like from the bookmaker that offered the highest odd, if it is bigger than 1 over the consensus probability of that result minus 0.05, which is a constant allowing us to make profit. So basically, we just check whether the probability with a little offset is good enough for us to be worth betting on. For that constant, values from 0.01 to 0.1 were experimented with, and this one yielded best payoff. If you went just one step higher to 0.06, it would be still equally profitable, but it would allow bets only roughly on half of the games as compared to 0.05. So these experiments were done on the 10 years of historically collected betting odds. And now the question is this like a working strategy, or is it basically random? So how do we find out? We just get random samples. We pick random matches with random results, and we bet the same amount. The bets throughout this presentation were $50 each. And we compare. And here you can see that the random strategy yielded an accuracy of about 39% and an average return of minus 3.3 on closing odds, while our strategy had some positive return. I'll give you the exact numbers a little later. What are closing odds? Those are the odds that are present for the match at the end of the closing, basically at the time the match starts, which also is not a time when you could actually bet, but it's the only bets you can get retrospectively. So a further experiment would be to look for the odds for matches like through time, check them real time, and place the bet sometimes between 5 and 1 hours to the start of the match. You can see that then the random bet strategy yields a much better return. It's actually 0.2, so it's even profitable, while the accuracy remains the same. But it's still performing much worse than our strategy. So we can confidently say that the strategy represented by that formula does work and actually gives us some positive results. All right, so next step, since the strategy seems to work, let's try making things more real. So this is a dashboard the authors of the paper created that basically scrapes betting size of 13 bookmakers and shows the promising bets, those that fulfill that criterion. And there on the right, you can see a bet button. That bet button doesn't actually bet, but what it does, it knows that you wanted to bet on this match and records the data and the odds. And then you can check how well you're betting, like you're performing through time. One thing they noticed when they started doing this is that compared to analyzing the old data, about 30% of the odds that were displayed on the dashboard were old, and when they tried to bet on them, they were not valid anymore because the scraping took time. That's also why there will be mature matches on the next slide. Okay, so now let's have a look at how it all worked. So on the historical closing odds, the strategy yielded a return of 3.5% over 56,000 bets. On the continuous odds, that means the odds coming shortly before the start of the match and not at the closing time. They tried that for some 6 months, and the return was 9.9%. They actually placed 7,000 bets. Then they went for paper trading, which is what I just described, pretending to place the bets at an actual specific time manually. And that part of the experiments yielded a 5.5% return on 400 bets. And since it all looked really, really promising, right? They went on to actual betting with real money, which they did for 5 months, and it yielded a return of 8.5%. So looks great, right? I mean, you're making money, 600 games, combined return 6.2%. That's not bad. Sometimes wish my shares did that. It works. Let's get rich. I want a Maserati. Anybody else wants a Maserati? Yeah, people do. Yeah, no, not happening. You're not meant to win. Similar to a casino, everything is set in a way where you can be lucky and win some amount of money, but always just at the expense of all the other people who lost. You're using a private service, and that private service, when providing the service, becomes a nuisance. That means when they start systematically losing money to you, they will just make you stop. They can detect when you are long-term winning, and then they can, for example, just limit the amount you can bet, or how often you can bet, or they just close your account, or do something else that ruins your strategy, which only works if you're doing it systematically. They will just make sure you're not going to win. And that is sadly the final answer. You can predict the results quite well, and there is a working strategy how to make money, but only in theory, because in practice, you won't be allowed to use it. These are the papers I drew my inspiration from, mostly number 3. If you're curious and you want to try how long they let you play and how much you can win, the entire code base for the experiments should be on that link and number 4. I checked the repo. It looks like it could work. I didn't try it. Feel free to use it, but don't blame me if you end up broke. Thank you. Questions?
Let me see. There are no questions on Slido. So if anyone has any question, please.
Janko has a question.